guys, welcome to the last lesson of Unit 1. This is Chapter 2, Lesson 6, and we're going to be talking about absolute value equations and inequalities. So at its basic level, absolute value is the distance from 0 on the number line, so it has to be positive. And so the best way to explain this is if you have 0 here, a -4, and +4. That distance between the two of them in either direction is 4 from 0. So that's why when you have the absolute value of 4, it's 4, and -4 is 4, because you're looking at that distance there. So when you're solving an absolute value equation, so the first thing you're going to do is get that absolute value by itself. So I don't care what's inside the absolute value, you're just going to get it by itself. Then the next thing is you're going to split the absolute value into two equations, one positive, one negative. And this is why, because we need to account for both possibilities of 4. We need to account for the -4 and the +4. And then we're going to finally solve. So let's worry about step 1 for number 1 here. So notice the junk out here. So I have a 5 and I have a 3 that I'm going to get rid of. And that's just getting the absolute value by itself. Okay, so then step 2, split the absolute value into two equations. So we do not touch what's inside the absolute value. So that's going to stay the same. So my two absolute value equations that are split are going to be 2x plus 7, 2x plus 7. Notice those don't change, but I'm going to say 1 is +3 and 1 is -3. And then finally, I'm going to solve for each equation. So this one, if I subtract 7 and divide by 2, I get x equals -2. And for this one, if I subtract 7 and divide by 2, I get x equals -5. Oops, sorry guys, I just realized that this is a -7, so I'm going to make this 2x minus 7 and -7. So that's going to give me a +5 for this one and a +2 for this one. So my two answers are x equals 2 and x equals 5. Okay, so 2 is a little bit easier, so go ahead and try that one. Okay, for number 3, we're just going to take this one, focus on the one on the right. It doesn't matter which one you choose, but we're going to do the same thing as like we would treat this one. So we're going to do positive and negative of this. So let me show you what this looks like. I'm going to say 2x minus 10 equals -x plus 2. That's going to give me the positive version of it. And then 2x minus 10 equals, I'm going to take the negative. So this is a negative. All the signs are going to change. So positive x minus 2. So I'm going to move this x over here. 3x equals, I'm going to do that 10 over 12. X equals 4. And I'm going to do the same thing. So move the x, 1x, move the 10 over, and I get 8. So don't let that scare you. It's not too difficult. Okay, so I want to show another weird case, number 4. So if you have a setup like this, they're trying to trick you because you can never have an absolute value by itself, isolated by itself, equal to a negative number. So there's no solution there. Go ahead and try number 5. Okay, so when you get rid of all the junk on the outside, it doesn't matter that this starts off as a positive. When you get down here, just like this one, and it ends up being a negative number, you're still going to say no solution, sorry, because it's equal to a negative number. Okay, now we're going to move on to absolute value inequalities. So if you have a great, I always like stress, greater than, this is an or, and ors are always unions, so everybody's coming together. Less than and is an and it is an intersection. So just what they have in common. So let's go to this problem, this word problem here. We have certain highway, there's a minimum speed of 45 miles an hour and a maximum speed of 70 miles per hour. Okay, so let's think about what the legal speeds are and what the illegal speeds are. So I'm going to use 45 and 70 as my limits on both of them. And let's just start with the legal speed. So can I drive 45? Yes, so that's going to be a closed dot. Can I drive 70? Yes, that's going to be a closed dot as well. So anywhere in here that I can drive is going to be okay. I'm not going to get a ticket. So I might write this in interval notation. Well, I might write it just like on a graph. We have a graph on the door as an expression, I guess I should say, as that. So going backwards, notice that that X is sandwiched in between there, and this is that intersection that we're talking about. Interval notation would look like 45 bracket 70 bracket. Okay, so let's talk about illegal speeds. So this is in the ticket range. So if it's less than 45, I'm going to get a ticket, and if it's more than 70, I'm going to get a ticket. So in this case, it's going to look like X is less than 45, or, so we have two different cases going on here, X is greater than 70. So my interval notation would look like negative infinity. So this is my upper limit for that one, 45. And then that union, 70 to positive infinity. Okay, so let's transition into solving absolute value type inequalities. Okay, so again, we're going to isolate the absolute value, which we've talked about before. A union is or, and an intersection is and. So make sure that you kind of get that straight in your head. We're going to solve each inequality, and then we're going to test the interval. So let's start here. So there's a couple different ways that you can write this, but like a less than is going to be sandwiched in between the positive and negative, and this is why. So the positive obviously would be x minus 4 is less than 5, but we also, remember it's an and, we also have x minus 4, and think about if I'm thinking about the negative version of that. So we'll sign and change that to a negative. So when I solve for this and I add 4 to both sides, I'm going to get 9 and negative 1. So it's between negative 1 and 9. So another way to look at this is to say negative 5 is less than x minus 4 is less than 5. I see most people do this. It's either one. This is like where that's coming from. So when we get down and we add 4 to everything, everything is already set up nicely. So I have negative 1 is less than x is less than 5. And so I'm going to graph it. So open dot, line connecting the two, and also interval notation would look like that. Okay, so on this one, the same thing is going to apply. So I'm going to have x minus 4 is greater than 5, or, so I'm going to do the same thing that we did over here, x minus 4, so I'm thinking about the negative, so it would be less than or equal to negative 5. So I'm going to add 4 to everything, and notice my values are the same, but definitely my direction of the way it's going, because it's an or, it's going to look a lot different. So this is going to be, and it's also equal to, so we're going to deal with the closed dots. So greater than 9 going to the right, less than -1 going to the left. So this is the one with the interval notation. It's going to be negative infinity to -1. And then union, because it's at 4, 9 to positive infinity. Okay, this one has some junk on the outside that's 6 and should be 7. So go ahead and get rid of the junk, and then, well, actually, let's go ahead and get rid of the junk together on this one. And then I'll turn it loose. So we're going to divide by 2, make x minus 1 is greater than or equal to 1. Okay, now I want you to split it and then also do problem number 8. Okay, so this is getting a little bit crazy, so I wanted to just take a stop and talk to you guys about this. So this one, we have x, the absolute value of x minus 1 is greater than 1. And so it ends up being, after we do the work, these two solutions, this is the graph, and this is the, this is the interval notation there. Over here, this is what we ended up with. So I suggested to keep it separate. So look at each one as its own. So I have x minus 1 is less than or equal to negative 2x plus 3. X minus 1 is greater than or equal to 2x minus 3. And then I'm going to solve. And so I got x is less than or equal to 4/3, and x is less than. So if we turn this around, that means the same thing. X is less than or equal to 2. So notice here that this is going to be an and, because of right there, I had to find it. So we're looking for the intersection. So where do these two have in common? So if I were to extend this out, they start having something common right there. So your final answer, goodness, I'm running out of space, is negative infinity, and then our ending would be 4/3, and that would be a bracket. So that one is pretty yucky. Okay, so this is another strange situation. So number 9 is very similar to number 8, and it's in the way it's set up. So I took some more time to kind of spread it out and show my work. So this is my work before I isolate it. So this is a less than problem. So think intersection. So what they have in common. So I split each one up. So this is the first one, and this is the second one. This one just played out normally. So I had x is less than or equal to 1. This one, the two x's canceled out. And so I was left with -1 is greater than or equal to -3. This is a true statement. So remember, any number will work there. So I showed my graph over here. And because it's an intersection, I'm interested in what they have in common. So they have up to 1 in common. So my answer would be negative infinity to 1 bracket. And I think I want to stop there because we've gone over a lot.